Okay, so in 4.4, we're going to work on exponential equations and logarithmic equations. So, and a lot depends on what you have, what they give you. Okay, so we're going to show you a concept how to solve exponential equations right now in this video. And I like this method. It doesn't always work, but I like this method. So you have an equation right here. It says 5 to the x equals 125. Well, we want to be able to solve for x. So how do we do that? You know, it's up there in the exponent. It's not like you can divide both sides by 5. Sometimes students try that, and that is wrong. Because that x, it's not 5 times x, it's 5 to the power of x. So you have to understand that. Okay, so we're not going to divide. But you might know the answer just by looking at it, right? So you're thinking, well, 5, and there's some exponent, and I know it equals 125. So what do I know about 125? Well, I know 125 is 5 cubed. Or if you didn't know that, you could get a calculator and probably figure it out pretty quick. Okay, so if I have 5 to the x equals 5 cubed, do I know what x is? X has to be 3. And you might have already been saying that. Okay, so here's the concept. If you have a base to some exponent equals a base to another exponent, then the, the two exponents have to be equal. Okay? So what we're doing is we're trying to get the bases the same. Get the bases the same. I'm going to match those bases. Now, you can't always do that. And so we have other methods when you can't. And also it has to be set up so that you only have one like term on the left, one term on the right. You can't have like other stuff like a +7 in there or something. It's just got to be base to a power equals the same base to some power. Okay? Then you can like pop out the powers. You're saying if this side equals this side, and I know the bases are the same, then the exponents have to be equal. You're not dividing by both sides by anything. You're not multiplying both sides by anything. You're not adding or subtracting both sides. You're just taking those exponents and you're popping them out. You're creating a new equation that sets the exponents equal to each other. Okay? So I'll show you how to do that on these next two examples. Sorry about that. So it's going all over the place today. Okay. I don't know why it wants to do that. All right. So you look at this first one in A, and we're trying to solve for x. So you see a base over here of 2. Well, 2 doesn't get more simple than that, so it's a pretty good base. So the question is, can I get 16 to be some power of 2? So I think about 16 and 2 times 2 times 2 times, how many of those, you know? All right, so I'm going to write 2 to the 3x minus 8 equals, and I know that 16 is 2 to the 4th power, okay? So that's what I want to do. I want to match those bases, get them the same. Then I can pop out the exponents and say they're equal to each other. So 3x minus 8 must equal 4. And that's the equation, and that I can solve. That's just a linear equation. Add 8 to both sides. So you get 3x equals 12. And then divide both sides by 3. Hopefully these are the fun steps. And you get x equals 4. And that's the answer. X equals 4. Okay? So these are pretty fun, but sometimes we have to think a little more creatively. So sorry about that. Okay, so here I have a 27 and I have a 9. Well, I'm not going to be able to turn 9 into 27 or 27 into 9. That doesn't work. But do they have some kind of base that's in common? Like what's common about 9 and 27? Well, they're both powers of 3. So 27 is 3 cubed, and 9 is 3 squared. So if I replace just the 27 with 3 cubed, and I'm putting exponents around this exponent here, because otherwise it's going to get tricky for me to read. And then I'm going to replace the 9 with 3 squared. And again, I've got that exponent in parentheses. Okay, now that's what I have. The rule of exponents says when you have a power and you're raising it to another power, you multiply those. So I can say 3 to the 3 times x plus 3 equals 3. And then the same thing here, I'm multiplying those powers. Those are rules of exponents. So I have 3 to the 2 times x minus 1. Okay, now the bases match. They're the same. So I'm going to pop out those exponents and create a new equation. I'm going to say this, 3 times x plus 3, equals this, 2 times x minus 1. Okay, that's an equation I can solve. I can distribute. I can subtract 2x from both sides. This is a linear equation. Subtract 9 from both sides, and I get x equals negative 11. Yay, that's the answer. So I find these equations kind of fun. You're trying to get those bases the same, and then you just pop out the exponents, okay? All right, good luck with those. They're fun.